Day 71 of doing a Leetcode problem every day until I get a job. All right, guys, welcome back for another day, another Leetcode problem. This time we're at day 71. I hope you guys are still excited as you were on day one. I hope you guys are still motivated, and I hope you guys are still staying disciplined and have all the intentions of staying disciplined, because we're just getting started for real and we have a long way to go, guys. But before we get started, don't forget. Bring your mouse right over here, and don't forget to click that subscribe button for me, guys. And then after you click that subscribe button, go ahead and smash that like button for me, guys. Then after you smash that like button, I'm calling all of my bankers to the comment section. I need you to go ahead and drop that bank emoji in the comment section so we can run this engagement up and we can help build this Swift community, guys, and we could bring this Swift awareness and get more people introduced and interested in Swift, so we could build the Swift community and help it grow as a whole and do our part in helping the Swift community grow, guys. Now, the part you all been waiting for, I know why you're here. Drum roll, please. Today, we have question number 17, letter combinations of a phone number. The difficulty level is medium, guys, but you already know we're still going to keep the solution as simple and easy to understand as possible, so do not get deterred. We understand that we're all trying to learn here, and so that's why we need to keep the solution easy to understand so that we all can learn. If you want to learn, you have to understand what it is that you're coding, and that's why we're going to keep the solution as simple and easy to understand. Now, if you want to understand the problem or the solution, the first thing you have to understand is the question. So let's get to it and see what it says. It says, given a string containing digits from 2 to 9 inclusive, return all possible letter combinations that the number could represent. Return the answer in any order. A mapping of digits to letters, just like on the telephone buttons, is given below. Note that 1 does not map to any letters. So what we want to do is find all the possible combinations that we can, given the digits, the input digits that they give us. We have the numbers. They have a picture of the telephone or the telephone numbers right here, so we can know which numbers correspond to each letters and how we're going to solve that and program that. So let's look at example 1 so we can see what they want us to do exactly. We have the input, then we have digits, 2, 3, right? 23. So the output is, this is the output right here: A, D, A, E, A, F, B, D, B, E, B, F, C, D, C, E, and C, F. So what they want is they want all the possible combinations that we could get from these two digits right here, 2 and 3. So if you look, we have 2 is A, B, C, D is E, D, E, F. We want all the possible combinations we could get. So if you look how it's set up, first it goes, we have A, first we're going to do the A's and get all of those combinations. So we have A, D, then we have A, E, then we have A, F. That's where these outputs right here come from the A's. That's how we get all the combinations from the A's. Then we're going to do the same things for the B's. So we go BD, then we go BE, then we go BF. That's how we got all the combinations for the B's right there. Then we're going to do the same thing for C, and it goes CD, CE, and CF. And now put them all together, and we have all the possible combinations that we can get from these two digits right here, 2 and 3. And that's how we got them, guys. So let's look at example 2, empty string, output a blank array. Then we have the example 3, which is digits. This time digits is 2. The only letters on 2 are A, B, and C. That's why the output is A, B, and C, because we didn't have to combine them with any other digits. We just needed that one number, that one digit right here, which is 2, and those letters are A, B, C. So now that we understand the question, let's see how we're going to code this, guys. And now the code is it's not that difficult. It's just it has a tedious aspect to it. But hey, we have to do what we have to do as programmers to make sure that the code works and we do what we're supposed to do, right? And that means we have to do what we have to do, and that means we have to do the tedious things as well. So the first thing we're going to do is we're going to declare a variable called map, and that's going to be a dictionary, and that dictionary is going to be a string, and then it's going to be an array of string, right? Then we're going to come over here and we are going to initialize that with each number in the phone book or in the phone on the phone. So first we're going to start with 2. So we're going to open up the quotation marks. We're going to put a 2 inside. We'll put the colons. Then we're going to open up the array brackets, because remember, the dictionary includes an array inside of the dictionary. So we're going to start right here, and we are going to create the letters for for 2. Excuse me. Then we're going to, so 2 has letters A, B, and C, right? Then we're going to put a comma outside of that array, but remember, we're still inside the initial array right here. And then we're going to come down here. We're going to do the same thing for 3. Then we're going to come over here. We're going to put we're going to put the colons. We're going to open up the array brackets, and we are going to say D. Then we're going to come over here. We're going to say E. We'll come over here. We'll say F. So in case you guys haven't noticed, this is the tedious part I was talking about, because we have to do it for every number on the phone and all the corresponding letters. So 4 has the letters G. Then we're going to put a comma. Then it has H. Then we're going to put the comma outside. Come outside of that. Put a comma. Then we're going to have the I. So that's 4 right there. We have to do the same thing for 5. So we're going to do 5. Oh, excuse me. Should be this regular colon, not a semicolon. Then we're going to do the same thing for 5. Excuse me, guys. Then, and we are going to, 5 has the letters J. Come outside that. Then it's going to have K. Come outside that. Then it's going to have L. Then we're going to do the same thing, guys, for 6, guys. Now, remember, this is what we have to do. We want to be good programmers, guys. We want to be the best programmers that we can be possible. So, in order to do that, we need to do all the tedious tasks that are required to be the best programmer to be. So, we're going to do this. So, now we're on 6. We're going to do, then it's the N. We're going to come outside. This. So, hope you guys staying motivated, guys. This is just part of the game. This is part of our life as a programmer. This is just what we have to do, the tedious task. So then, come over here. 7 has, 7 is going to have P. We'll come outside the P. Then it has a Q. Come outside the Q. And it's going to have an R. Come on, see, 7 is a little different because it has 4 numbers. 7 has a S as well. If you curious where the letters are coming from, we're just getting the letters from this picture of the phone numbers right here. Then we're going to come outside here, put a comma. Oops, don't forget the comma right here as well. Come down here. We'll put 8. Then come outside that, put the colon. Open up the brackets. Then we're going to put T. Come over here. We're going to put U. Come over here. We're going to put a V. Then we're going to come over here, put the comma, and now we're doing 9, the last number. And 9 has 4 letters as well. So we're going to put a colon, open up the brackets. Then we're going to put the quotation marks. We're going to do the W. Then we are going to do the X. Then we are going to do the Y. And then we are going to do the Z, guys. And that is it for that one part. That was the most tedious task that we had to do for this code, guys, but it had to be done because we needed a reference for our function to reference to actually know what numbers correspond to each letter. So now that we have created that reference that we can use, now it's time to do the code, the easy part. Or I'm not going to say the easy part, I'm going to say the less tedious task, which is creating the function. And to do that, first we are going to declare a variable called res. We're going to pass that as a string, and we're going to initialize that with a blank array. Excuse me. So res, we're going to cast it as an array of strings. Excuse me, and we're going to initialize it with a blank array. Then we're going to come down here. We're going to say for D in digits. Excuse me, guys. For D in digits, we are going to say let C equal string. String D. Then we're going to come down here and we're going to declare a variable called candidates, and we are going to set that equal to a map of C, and that's going to be optional, guys, so put a exclamation point after that. Then we're going to come down here and we're going to say if res dot is empty, then what we are going to do is we're going to say res dot append, open up the parentheses, we're going to say contents of colon candidates. Excuse me, had to check my spelling, guys, make sure the spelling's right. Then we're going to come down here and we're going to say else. We're going to declare a new variable called new res, and we're going to set that equal to, we're going to set that equal to an array of string. We're going to put the parentheses outside of that. Then we are going to come down here and we are going to say, for C and candidates, we are going to say res dot for each, open up the brackets, and we're going to say new res dot append $0 plus C. Then we're going to come down here. We're going to come underneath all of that. We're going to say res equals new res. Then we're going to come down here and we are going to say return return res. Now remember, guys, in case you're wondering, remember this $0 is going to represent every element that we're dealing with in the array that we're dealing with. So that's why, and then it's gonna just add that to each C or each digit to see what it needs to add to, etc. But just so you guys know, because I remember it took me a while to understand what this $0 did. Now, let's run this and see what happens. Let's see, fingers crossed. And it's accepted, guys, so let's submit it and see what that time is looking like. Fingers crossed, fingers crossed. 5 milliseconds beats 48.93% of users with Swift, guys. That's not bad. Not bad at all. We could get it up, but we're still learning, and I feel like this is a simple, easy solution to understand for everybody that's learning like myself. So get one more look at the code, and I will see you guys tomorrow for another day, another Leetcode problem. Peace.